Welcome everyone to my new lecture where we are going to learn about the induced EMF or induced voltage. Those things for me are the same, not so very big difference. So, for example, here you have an iron, and around on the iron you have a solenoid. So, from here to here you have those loops. So now it is attached parallel with a voltmeter. And now, as you can see, when there is no current flow, there is no power source here, the voltmeter shows 0. So here you have 0. But let us bring a magnet to these solenoids. Now, we have a magnet. For example, here you have the North Pole and here you have the South Pole. And we are going to put the magnetic field with some velocity into the iron. Here we have space, a circle here, and you have a space. So when you move a magnet towards into the solenoid or around it, then you will see that this voltmeter is going to show you that there is some kind of voltage, positive or minus. It all depends in which direction the voltage is. In which direction the voltage or the EMF shows. So, for example, you have now here in the right side. Later on, in my next lecture, or in 2 lectures, I'm going to show you how do you know in which direction the EMF is going to show. So, when you put this magnet into the solenoid, then the voltmeter is going to show you in one direction. If you put the magnet into the solenoid and leave it there, then there is no there is no induced EMF. This word induced, that means made, like there is an EMF made in the solenoid. Induced. Okay. So now if you put into it and just leave it there, there is no movement, there is no speed, there is no velocity, then it's gonna show you again 0. Okay, so the north side went in. Now in the solenoid. So now we want to pull it back out of the solenoid, like this, and then this voltmeter is going to show you the induced EMF, but in the other direction. So there is a formula which you can calculate what is the induced EMF value. So, okay, for the unit for induced EMF is volts. As you know, this is induced EMF. Okay, so magnetic induction in Teslas, okay, times the length of the conductor that's found in the magnetic field, and times the speed or velocity, that's not really important, of the it's important in which direction you are going. So you can put here velocity of the conductor that is found in the magnetic field. Okay, so that is the formula, and usually we don't put I don't know, magnets into the solenoid, So for example, here you have a magnet north, south, and here we have another magnet south, north, and they are attached to some wall, like you see. Okay, the magnetic field is going to show you in this direction, and you put a conducting rod, and it goes, and if it just stays like this, there is no induced EMF. If it goes in this direction or in this direction, then you will have induced EMF or an induced voltage on this rod. Okay, so that's for the induced EMF. Thank you for watching and see you in my next lecture.